Now this problem says we have a spiral. So a wire has been found a spiral, planar spiral. So thin insulated wire. So this means wire has been a cover. And this wire forms a spiral. So this is the lower end. And this forms a spiral. And the total number of turn is 100, that is n, that is given to you. So n is the total number of turns. So n is given to you. So n is total number of turns that is given to you. So n is given. And the inner radius, that is also given. So inner radius is A and the outer radius is B, that is also given to you. We have to find the magnetic field at the center. So what we have to find? So we have to find B at the center of a spiral. So at center. So how will you proceed for this part? So this is quite tricky. So let us say what we will do is we will use a result, that is due to the circle you have. So if you have a circle, due to the circle center, so if you have a circle somewhere here and magnetic field at the center, if you have a current I in this, I know B is given by mu naught I by 2R. Are you getting or not? So this is simply mu naught I by 2R. So this is due to the circle. Now I will use this idea. So you see how we will use. So let us say this is my spiral. So slightly difficult to make. So this is my spiral. Okay, now finish this one here. So this is my spiral. Are you getting or not? So what I will do is, so let us take a distance r from here. So I am making another diagram. So this is distance r. So at distance r, I will have a circle. And now I can assume there are some more circles. So this is one circle, we will have some more circle. Let us say thickness is dr. So I am next considering next circle is of radius r plus dr. Are you getting or not? So this is my circle, next circle I have, and that is the radius r plus dr. So this is r and this is r plus dr. This means this thickness is dr. Now I know the total number of turns. So this is inner radius is A and the outer radius is B. So outer radius is B and total number of turns is n. So now I can say in a length of B minus A I have n turns. So what is the turn per unit length? So I can say B minus A divided n divided by B minus n. That is the number of turns per unit length. So this is nothing but number of turns. So this is number of turns per unit length. Are you getting or not? So this is easy. Now how to find what is the total number of turn in dr width? So you have a dr width and I know the per unit length. So now I can find total number of turns in dr width. Total number of turns in dr width. Easy. So now I can say this is nothing but n by b minus a into dr, because n by b minus a is number of turns per unit length. Now I can assume these all turns are kept at a radius of r, because this dr is very small. So therefore these all turns, there are many turns in this width. Due to all these turns, magnetic field at center can be simply given as mu naught I by r. So I can write dV is equals to mu naught I by 2r. R is the distance, r is the radius. Now you see, what is the I? I we will have, this is I, but I have not n turns, I have to have some different turns, n dash, and this is same as this. So I can plug this value here and now things are easy. So now I can write dV is equals to n by b minus a into dr and mu naught I by 2r. So this is the total number of turns in dr width, and this is the mu naught I by 2r. Now I have to integrate simply. So if I integrate this one, this side I have to integrate, and this side also I have to integrate. I have to integrate total magnetic field 0 to B, and the radius goes from A to B. So this side I will have total magnetic field B. And now if n by B minus f, so things are constant, I can take common. Mu naught is constant, I is constant, n is constant, divided by 2 times B minus A, that is also constant. So I am only left with 1 by r, so dr by r. Integrating on this, I have to integrate from A to B. So things are simple. Now this means B is equals to mu naught I n divided by 2 times B minus A, and integration of this is ln r, so this is simply ln B by A. So this is your total magnetic field. Are you getting or not? So this is your magnetic field. This you have to find in the first part of the question. So due to the spiral, this will be the magnetic field mu naught I n 2B minus A ln B by A. Now the second part of the question says calculate the magnetic moment of a spiral with a given current. So we have to calculate magnetic moment. If you remember what is magnetic moment, so B part, we have to calculate magnetic moment. So we have to calculate magnetic moment. So what is this? If you remember, so this is magnetic moment. So if you remember, this is mu is nothing but I times A, that is the magnetic moment. Did you remember or not? And this is due to the one loop. So you have one circular loop. So let us say again, you think in the same direction. So you have this. So let us say I have a circular portion here, and this is radius r. And the next circular portion I can think of radius r plus dr. So this means this width is dr. Are you getting or not? So this is r and this is r plus dr. So this width is dr. Are you getting? Now due to this, so let us say this circular portion. So this circular wire. So this circular wire, what is the total magnetic moment? But there is an n number of turns. So n dash, we have already calculated n dash is equals to n by B minus A into dr. So this is the total number of turns in this thickness. So due to one thickness, due to one wire, what will be the mu? So due to one wire, I can write d mu is equals to I times area. Area is pi r square. So this is due to one wire. But there are n dash wire. Are you getting or not? So what is the total? So there are n dash wire, there are n dash loop. So I can write total magnetic moment. You see another important point, I and A, area vector. So this is a dipole moment is a vector, magnetic moment is a vector. I am only interested in magnitude right now. So now I can write total magnetic moment. So this is total magnetic moment. So this will be, total magnetic moment will be, this is d mu times n dash, and we have already calculated n dash. N dash is nothing but n by B minus A, n by B minus A into dr into I times pi r square. Now if I integrate this magnetic moment, so I will get the total magnetic moment mu. Mu is equals to, I have to integrate this one. R goes from A to B, and this goes from 0 to mu, so that is basically mu. So mu is nothing but n by B minus A is a constant. I can take this outside. Other thing, I and pi is also constant, so I can be get outside, and pi is also a constant. So I will be left with r square dr. So I have to integrate from A to B. Are you getting or not? Simple. Now if you integrate this one, so you will have n I pi B minus A, and this is RQ by 3, that is BQ minus AQ by 3. I think everybody can understand this is simple integration. So you will have, finally I can write this is pi so I will have ni pi bq minus aq divided by 3 times b minus a. So this is the final answer you will have.